Hello everyone and welcome to our week 6 lecture. Today I wanted to talk a little bit about the Python Pandas library because we will be using it in our assignment this week. So I'll start off by doing a quick PowerPoint presentation about Pandas to cover some overview information. Then I'll show you many code examples using the Pandas library. And finally I will show you how to complete the Python assignment for this week. So let's get started. Alright, so first things first, what is Pandas? Well, Pandas is a Python library used for working with datasets. It's really an amazing library that makes working with data so much easier and faster. Pandas has functions for analyzing, cleaning, exploring, and manipulating data. And a very common question that is always asked, why is it called Pandas? Well, when I did my research, I found that the name Pandas has a reference to both panel data and Python data analysis. So I guess we can see how these words can be morphed into a catchier name like Pandas. And I believe we owe a huge debt of gratitude to a software developer by the name of Wes McKinney, who back in 2008 created and introduced Pandas to the world. It really makes a big difference when working with data to have this Pandas library available to us. Alright, so we use Pandas because it allows us to analyze big data and make conclusions. Pandas can simply clean messy datasets and make them readable and relevant, which is a key benefit. We go from raw data to information that we can use in our decision-making process. For example, Pandas can help us to find correlations between two or more columns of data, and we can also quickly find average values or the min and max in any column. We can also export datasets to Excel and CSV files, all through the Pandas library. Now there are some new terminologies that we need to learn about when working with Pandas. I picked the three most common terms, which are series, data frames, and labels. So a Pandas series is like a column in a table. It is a one-dimensional list holding data of any type, like strings or integers. Then we have labels, which are basically identifiers of the values of our data. You see, in Pandas data tables, each row also has a name, and this name is what we call a label. And by default, this label is just the row number. However, you can set one of your columns to be the index of your table, which means that its values will be used as row labels. Now we set the column name as our index, and if no labels are used, then it is defaulted to index numbers, where the first item is index 0, then second item is index 1, and so on. And the last term I wanted to share with you is data frame. A Pandas data frame is a two-dimensional data structure, like a two-dimensional list, for example. But in simplest terms, it's better described as just a table with rows and columns, as you can see from this image here. And the beauty and simplicity of data frames is that we can load files of data right into it, like a CSV file, and we can also send the data from the data frame to a SQL database. So very powerful stuff with very little lines of code. Okay, here I have a Jupyter notebook with a lot of examples using Pandas, and I separate them with different cells so we can run them one at a time. Now the first thing we need to do to start using Pandas is we have to import it, but before importing it and actually using it, we have to install it. So if you go to a command line prompt, and we run the command pip3 followed by the word install, followed by the name of the library, which in this case is Pandas, hit enter. Now based on the result here, I already have it installed, but if you didn't have it installed yet, it's going to start to download and then install the Pandas library for you. So first thing you need to do is make sure that you have it installed so we can start using it in our code. Now to use it in our code, first thing we have to do again, we have to import the Pandas library. Now I'm going to alias it using the as reserved keyword just as PD. So instead of writing Pandas every time, I'm just going to type PD for short. Okay, now one of the classes in a Pandas library is the series class. And series class is part of the Pandas library, so pd.series. Okay, and the series is going to give us a one-dimensional set of data, and our data has been defined here as a list of these integers. So we have a list called data, and the assigned values are a list of 1, 3, 5, 7, 9, which are just integers. So I'm going to create a series from my Pandas library, and it's expecting that I pass it some data because I have to build the column using some sort of data, and this data is this list here. Now this is going to return a one-dimensional column, and I'm going to assign that a value called series. Then I'm just going to print out my series to see what I get back. Alright, so before I run this, let's run this import statement. Okay, get a check mark, and now let's run this second statement. And there we go. So I got my one-dimensional list as a column, and the column on the left here, this is the index column. And again, index are 0 base, so 0, 1, 2, 3, 4. So this is considered my label. My index column is my label. So for value 5, the label is 2. For value 9, label is 4. You can think of them as row numbers, so row number 0, row number 1, row number 2, and so on. Now, you don't have to stick with this default index column. In the next example, we're going to create what is called a custom index column. So I'm going to start again with my one-dimensional data set, which is a list, same data. Then I'm going to create another list. I'm going to call it custom_index, and I'm going to give it the values of A, B, C, D, and E. So the goal is, instead of having a default index column of integers, I'm going to have a custom index column of letters. And again, you could call it anything you want, of course. I'm just going with a very simple example of just simple letters. Now, we're going to do the same thing. We're going to call the series class in my Pandas library. I'm going to pass it the data, just like I did before, which is this data here. But instead of closing my class, I'm going to pass another argument or another attribute called index. And I'm going to set it equal to custom_index. And the custom_index is basically these values here. I'm going to create a series object for my pandas, pass it this data, and instead of using the default 0, 1, 2, 3, 4 for my index column, I'm going to be using the custom index, which is A, B, C, D, E. This all is going to be stored into a new variable called series with _custom_index, and then I'm just going to print it out. So let's run this and see what we get back. And there we go. Instead of having default index values as labels, now I have custom index values. But just please make sure that the number of data equals the number of index. For example, if I create another index here, call it x, and then run this, I get a value error because I don't have the length of values does not match the length of index. So make sure that your code, if you're going to be using custom indexes, that it matches correctly. Now, if you don't want any index column at all, you just want the data to show up, then what we can do is, in my series class, we can call the to_string method and then pass it the index value equal to false. So I'm going to take my existing series, which again I've built from here, and then I'm going to convert it to toString method in my series class. I just have to pass it the value or the attribute of index equals to false so that I don't get any index column regardless if it's default or custom. I'm just going to get the data basically. So let's run this, and that's exactly what I get, just the data. In my next cell example, I can build a pandas series from a dictionary. Now a dictionary basically has key and value pairs, key and value, key and value. So that's going to be my data. It's a dictionary because it has braces around it, and then it has key value pairs. So I'm going to build my series in my pandas library and pass it the data that's called data. Now let's see what this is going to print out for us. So based on the output here, I can say then that the index column has basically taken value from our key, and then the values are from the values portion of the dictionary. Okay, so that was kind of a quick way to create both a label and the data using a dictionary data type. The next code example is another method that we can apply to series, and basically just from the name it says to_CSV. So this is going to take the data that's in my series object and it's going to send it to a CSV file, and the name of the CSV file, you pass it as the argument in the toCSV method call. So this data is going to be sent to a CSV file called week6-CSV data. So if I run this, I get a check mark, And then let's open up the week 6 CSV data file. And here's the file that opens up. Again, we have the label or the index column as ABC. And then for the values, we have 10, 20, and 30. And this is the week 6 CSV data file. Now, notice here I have a 0 for my header for this data. We actually could control this and we could create it into something else. So let me close this file first and go back to the code. In my next code cell, I'm creating a custom header or a variable called custom header, and I'm going to set it equal to a list with just one string value. So this is going to be the header that I'm going to use for the data column that I saw a moment ago. And again, we're going to do the same series.csv method call. I'm going to pass it the name of the CSV file. I kind of named it differently just so you can see the difference in the file name. And then I'm going to add a new attribute called header, and the header is going to equal to custom_header, which is this. So for the header information, I'm not going to use the default, which is index numbering system. I'm going to be using a custom header called custom header, and the value is number. So if I run this, and let's open up that CSV data file with header. Okay, there we go. So this is the week 6 CSV data with header. And now instead of having a 0 for the header, now it's number. So with Pandas, there's a lot of functionality, there's a lot of flexibility, there's a lot of powerful things we can do. And right here, I'm just scratching the surface for you guys. Alright, the next cell is basically going to start introducing us to data frames. So far we've been talking about series, which are just one-dimensional data columns. But most of the times we're working with table-like data where we have columns and rows, and that's where data frame comes in. So in Pandas, just like we had a series class, we also have a data frame class. And data frame class also takes some sort of data, and what that's going to do is it's going to create a data frame object for us. And in this case, I'm assigning it a new variable name called df. You can call it anything you want, of course, but I'm choosing to call it df, which is data frame for short. And what is my data? Well, my data is up here, and basically it's a dictionary, again, of 3 keys, and each key has values that is made up of a list. So name is going to be my first key, and it has Alice, Bob, and Charlie. And then next key is age, 25, 30, 22, and the last key is city, New York, San Francisco, and Los Angeles. Now just quickly to recap, up here, when we did the Pandas series with a dictionary, the result was that the key values were the label and the actual values were the data column. Okay, let's see how different now it's going to be when we do data frame from a dictionary. So let's run this. Okay, so now my key values or my key names become my header, while the data or the values in my keys become the actual data. Okay, so just keep that in mind. When you're working with dictionaries, in data frames, the key names become the headers, and then the data becomes the data, while in a series, the key names become the labels or the index values. Okay? Alright, now very similar to what we've seen before, where if you don't want this column, this index column, then we need to call the toString method on our data frame object, and then pass it the index attribute and set equal to false. So if I run this as is, I get the same exact data minus the index column. Okay, so call the to_string method, so we have to convert the data in our data frame to a string, but then drop the index column by setting the attribute index equals to false. Now if you wanted just one of the columns instead of the entire data frame, then you can basically say don't print out the entire df, which is the data frame object, but you can just print the data frame and then pass it in brackets the name of the column that you want to view. So if I do run, now I only see the name column, which basically is this column here, and the data is Alice, Bob, and Charlie, and that's exactly what I get back here. So again, you have full control of what you want to see and how you want to see it. Next code cell is gonna bring us into the read_CSV method. So again, the Pandas library has a lot of methods that's available to us. We saw the toString. Now there's also a read_CSV. So we can read data from many data sources. You can read from a CSV file, you can read from an Excel file, you could read from JSON, you could read from a database, and so on. And you can also go the other way around. You could send to a CSV file, you can send to a SQL database, and so on. So this code example basically is going to say, I want to read from a CSV file, and the CSV file is called week6-data.csv. Now you have to make sure that this file exists before running this code, because if it doesn't exist, then when you run it, you're going to get an error. So what this code is going to do is it's going to read data from this file. It's going to dump it into a data frame object, and then the data frame object is going to be assigned a variable name called df_csv. Then I'm going to print out this data frame object. So when we run this, I get that. So basically, this is data from, let me open up the file for you, this file here. It's called week6-data. It's a CSV file, and it has 4 columns: duration, pulse, max pulse, and calories, and it has all this data here. And we have about 170 rows with a row of headers. So if we go back to our code, basically here we have the column headers correctly displayed, and we have, it starts at 0 and goes all the way down to 168. We have 169 rows times 4 columns, which is correct. Now you might be wondering or asking, what are these ... here? Basically, in Jupyter Notebook by default, or when working with Panda data frames by default, you don't get the entire data set back because it could be huge. Okay, so what it does is it gives us the first 5 records, and then the last 5 records, and then the ... basically tells us that there's some data in the middle which is currently hidden. You technically can see the entire data. There is a set option, which is a method in Panda data frames, and you can set it to none, and then it's going to display all the records for you. But by default, it's always better just to get a small piece of the pie, just to make sure that you are getting the data correctly. And if you do want to see the entire thing, then you can use the set option, and that will display the entire data set for you. Moving on to the next cell, there is a method called head, which is part of the data frame object. So once you have a data frame object, you can call all its methods, and one of them is head. We have head and we have tail. So head, as you can guess it, is going to give you first set of rows. Now how many set of rows? Well, let's run this and see what we get back. Okay, so we get the first 5 set of rows. Now the head method, if you don't pass it anything in the argument, it's going to return by default 5 records. But you can also say 3, and then run it again, and you get the first 3. So the head method of the data frame object is going to return by default 5 records, but if you want less or more, then you can specify it here. Now the opposite of head is tail. So again, tail is a method that you can call on your data frame object, and if you run it, it's going to run and return the last 5 records in your data set. And just like head, we can also control, how many end records we want to see. When we run this, 2, we only get 2 back. So again, head and tail are one of the many methods we can apply to a data frame. Another method is info. Now, info is going to give us some information about our data frame. So I have the data frame name, followed by dot notation, followed by the info method. And if we run this, we get some information back. So we get that it's a data frame class. The range index is, we have 169 entries from 0 to 168, which is correct. Again, you can see this from the index column. We get 4 columns back, and the column names are duration, pulse, max pulse, calories. Do we have any non-nulls? No, we don't have any non-nulls. And then we have any data types. First column is an integer, second is an integer, third is an integer, and the last is a float. Okay, so again, the info method helps us to see some information regarding our data frame. Now, if you want to get some statistical information about the data you're working with, there is a describe method, which is part also of the data frame Panda object. So you call the data frame name, dot notation, describe method, and let's run this. And what this does is it gives us the 4 columns, but it also gives us the statistical information for count, mean, standard deviation, the min, the max, and then the different percentiles at 25, 50, and 75. And it does that for every single column. So pretty handy and pretty quick just by using the describe method. For our next few cells, we're going to start working with methods that allow us to clean up data or work with data to prepare it so that it's clean and ready for use. For example, one of the methods we can use is the drop NA. So the drop NA is basically going to drop any missing values in your data so that we don't create any outliers or skew our data somehow. So for our data, I'm going to create a new data frame called df_missing. It's going to be a data frame which is part of the Pandas library, and the data, I basically hard-coded it here. It's a dictionary of 2 key value pairs. The first key is A, and then the values are a list of integers 1, 2, none, which basically is a missing value, 4. And then for my second key value pair, I have B, and the values are none, 3, 7, and 8. So we can see that the third element in my A column is missing, and my first element in my B column is missing. Now I'm going to print the df missing data frame before I do any changes to it. Then I'm going to give some extra spaces so you can differentiate between this print statement and the next print statement. Then I'm going to call the drop NA method, which is part of the data frame object, and basically this is going to drop any row that has empty values. Once I do that, I'm going to save it into a variable called dfMissing, which is the same name. Okay, I made a change, and then I want to apply it to the name of the data frame. Then I'm going to print the data frame after I made this change, which is the drop NA method. So basically I'm going to populate the data frame called dfMissing with this data, which has some missing rows. I'm going to print the data frame as is with the missing data. Then I'm going to call the drop NA method, which is going to drop this row and this row. Then I'm going to print the data frame again to see what it looks like after the change. So let's run this. Okay, so the original data set, the first row has an empty value here. NaN is not applicable number. And then on the third row, there's also a non-applicable number. So technically this row and this row should be dropped when I run the drop NA method. And down here, that's the df missing data frame. And again, we dropped the 0 row. You don't see a 0 index here. And we dropped the 2 row. So now our clean data frame has data and it doesn't have any missing data. Another thing we can also do while cleaning up our data is dropping duplicates. So just like here we dropped NAs, we can also drop duplicates. And this method is called drop_duplicates, and it's part of the data frame object. So just like the previous example, I'm going to populate a data frame, call it dfDuplicates, and the data is 2 key value pairs. The first one is called A with values 1, 2, 2, 4. Second one is called B with values of 5, 6, 6, 8. Then I'm going to print the data frame. I'm going to leave some spaces after it. Then I'm going to call the drop_duplicates method on my dfDuplicates data frame, and then I'm going to print it again to see what the change looks like. So let's run this. Alright, so here I have a row that has 1, 5 as values, and then I have 2, 6 as values, and I have again 2, 6 as values. And then down here, when I ran the drop duplicates and printed it out, this is the updated data frame, and you can see that here I had 2 rows with 2 6s, and now here I only have 1 row with 2 and 6s. So row number 2, which had 2 and 6, got dropped here because it's already duplicated from the 2 and 6 in row number 1. The next example is that we can also do some filtering on our data. So I'm going to start again with the same data that I had a few examples up, which is name, age, city with different values. And then I'm going to create a data frame from this data. I'm going to call the data frame df. Then I'm going to print the df just before I make the filtering. And I'm going to leave some spaces after it. And then I'm going to do the filtration here. So the filtration basically says, in my data frame, filter out the age column in that data frame where the values are larger than 25. So basically in my age column, I have values 25, I have 30, I have 22. So technically the only data that fits this criteria, where the age is larger than 25, it's not this value, it is this value, it's not this value. So just this record or this row holding this age value should appear in my data frame. Now here, my original data frame is called df, but then after this criteria is met, I'm going to create a new data frame called df_filtered, and that's what I'm going to print out. Okay, so I'm going to first print out the original data frame. I'm going to filter the data, create a new data frame, and then I'm going to print a new data frame with that filtered data. So let's run this. Here's my original data frame with all the data in it, and then here's the filtered data frame with just anything of an age value greater than 25. Another thing we can also do is not just filter our data, but we can also sort our data. So in data frames, we also have another method called sort_values, and it takes an argument called by, and we set it equal to the column name. So df is this data frame here with this data. I'm going to call the sort_values method on it, and I'm going to sort my data by age. So here's the age column, and by default everything is always sorted. If it's strings, it's going to be alphabetically. If it's numbers or integers, it's going to be from smallest to biggest. So then this should come as 22 first, and then 25, and then 30. Okay, so let's run this and see what we get back. That's exactly what we get back, 22, 25, 30. Now if you want to swap the order, then I could basically add another attribute called ascending, and then set it equal to false, because the default is true. So that's why we don't have to specify it. But if you want to flip it, then you have to add the ascending attribute and set it equal to false. Now if you run this, then the age now has been flipped, so it's biggest to smallest. Now for the week 6 assignment, we have the typical Python assignment as well as the R assignment. And for this assignment, we're also going to be using a CSV file, which is provided at the very bottom. Here it is, so please download this file because we're going to be using it. Now I'm going to show you the Python part of this assignment. And again, there's a lot of steps that we have to do. And so I'm going to share with you my Python code so you could learn from it. And then you can also give it a shot and work with the R code on your own. So here is the CSV file that is provided for us. I call it coffee shop. And it has these columns: drink, payment, tip, total, brief, and order type, and it's filled with data. Okay, so that's the file that's been provided for us. You just have to download it. And here's my interpretation of the code for this assignment. We're going to be using Pandas, so you have to import it first, and of course if you haven't installed it yet, please make sure that you install it from a command line prompt. Okay, so the first step it says is import the fictitious coffee shop CSV file to a data frame. Now in data frames, we have a method called read_CSV, and you just have to provide it the name of the CSV file. Make sure the name, whatever name you're using, is the name of the actual file. And here I'm not specifying a file path because my CSV file is in the same exact location as my Py file. So this code file, this Python code file, is in the same folder or directory as this coffee shop.csv file. If it wasn't, then I did have to specify the full path here. But for simplicity purposes, I put both the code file and the data file in the same folder. So I'm going to call the read_CSV method in my pandas library. I'm going to pass it the name of the file. What this is going to do is it's going to create a data frame object, and I'm going to assign it a name called coffee_original. So that's step number 1. Step number 2 says export coffee original to a Microsoft Excel with data as the sheet name. So here we read data into a data frame. Now we're going to take that data frame and export the data to an Excel file. So read underscore means you're getting data into the Panda data frame. To underscore means that you're exporting data from the data frame to some sort of a data destination. In this case, it's going to be an Excel file, and I'm going to call it coffee_original. And I can stop here, but the instructions say make sure that you call the sheet name of that Excel file data, and it also is asking us to make sure that you don't include a index column, which is the default behavior of having an index column starting from 0, 1, 2, 3, and so on. Then the next step is import the Coffee original XLS back into a Python Pandas data frame. So after I've exported the data into an Excel file, I'm going to go backward again. I'm going to read from Excel. There's another method called read_Excel, just like I have read_CSV. And I'm going to read data from this Excel file, which is part of the Pandas data frame, and then create a new data frame called coffee_version2. Okay, so again, read from the original CSV file that was provided, export that data frame to an XLS file, then read that data into a new data frame with a sheet name called data. And once we have that, then we want to modify this Excel sheet, or actually we want to modify this data frame by adding a record number column called record to coffee version 2. So here's my coffee version 2 already created, which is data from this Excel file. Then I'm going to add a new column as the very first column, because it says add a record number column. So there is a method called insert in a data frame. I'm going to call the insert method. I'm going to pass it, first thing is the index location of this column. So index location 0 is the very first column. Next argument is, what do you want to call this column? I'm going to call it record. And how many do I want to add? I want to add starting from 1 to as many records that I have in my data frame plus 1. Why plus 1? Well, because the first line is index 0. Okay, so I'm going to call the insert method on my data frame. I'm going to insert a column called record at the very beginning, and it's going to go for starting from 1 all the way to as long as I have records plus 1. Then I'm going to take this data frame coffee version 2. I'm going to assign it a new data frame. Basically, I'm going to rename it so I could work with a fresh set of data frame. And then I'm going to export whatever is in data frame version 3 to a CSV file. So I'm going to take whatever is in this data frame, I'm going to send it to a CSV file. I'm going to call the CSV file coffee_version 3, and I'm not going to need any index columns because I already have an index column that I specified up here as a record column. So that's going to be my coffee version 3. Next, I'm going to import coffee version 3 back into Python. So to import back into Python, where you have a data frame, you're going to, from the Pandas library, you're going to call the read_CSV method. You're going to pass it the name of the file, and then that's going to create a data frame for us, and we're going to call that data frame coffee version 4. Now that coffee version 4, we're going to sort the data in it by total. Now the instructions in our assignment incorrectly says to sort the coffee version 4 by year. And if you look at the data, there is no year column. So I'm changing it to total. So just in case you don't get thrown off by this, we're not going to be sorting by year. We're going to be sorting by total. So in my code example, I'm taking the coffee version 4. I'm going to call the sort_values, which you've seen a few minutes ago. This is a method that allows us to sort data in our data frame, and we use the by attribute and we set it equal to the name of the column. So in this case, it's going to be the total column. And smallest to largest, that's the default, so I don't have to specify the ascending equals to false attribute. And that's going to give us a data frame. I'm going to call it coffee version 4. Next is export the revised coffee version 4 data frame to a Microsoft Excel file. So again, when you export, you do the _, whatever the data destination that you want to use. So in this case, it's an Excel file, so I'm going to call the _Excel method on my data frame. You have to give it the name of the Excel file. If you want to give it any more attributes, like what do you want to call the sheet name, or we're going to call it data, because you know Excel files have well, an Excel file is a workbook, and inside that workbook we have multiple sheets. Just like here, this is a workbook, and here we have sheets. So this is the coffee shop sheet, and here you can have more sheets, more sheets, and more sheets. So the entire file is a workbook, but inside that workbook we have different sheets. Okay. Now the next step in the assignment says adjust the column widths and export it to a final Excel file. Now even though the assignment says not to use any libraries other than Pandas and maybe OS, I'm telling you to please go ahead and import this extra library called OpenPyXL. Now OpenPyXL is not a built-in library in Excel, just like Pandas, so you have to install it. So when we go to a command line prompt, you would do pip3 followed by the install command followed by the name of the library, which is in this case is OpenPyXL. Hit enter. Now for me, I already have it installed, but in your case, if you run it the first time, it will say downloading and then it's going to say installing. Once it's installed, then you can start using it in your code. Now there are a couple of ways you can import libraries. The first or the easiest way is just to say import followed by the library name. Now I always like to use the as so I can alias my library with just short letters. But the other way is if you know you're not going to use everything in the library is huge, and again it takes a lot of space, it takes a lot of overhead. So if you don't want to do that and you know that you're going to use something very small in your huge library, then another way you can do it is say from the library name import just the class or the function that you want to use. Okay, so again here I'm going to import the entire OpenPyXL library, and I know I'm not going to use many things in it, but that's okay. That's one way to do it. The other way, or the more efficient way, is to say from the library name import just the library, or just the function that you want to use. And even within the actual library there's modules that you can also import from. So from the OpenPyXL.utils module, just import this function. Okay, so these are just a couple of ways that you could use the import command. If you don't want the entire library and you just want a function from a module, then you can do it this way as well. But for now, let's just stick to the importing the whole thing. But that's not the most efficient way though, just so you know. Okay, so what I'm going to be doing here is I'm going to be calling the load workbook method, which is part of the OpenPyXL library. I'm going to pass it the name of the file, the last file that I've been working with, which is the coffee version 4. And I'm going to load all that into a workbook variable. Then that workbook variable, I don't want the entire workbook. Again, like here, I don't want the entire file. I just want this sheet. Okay, well, not the specific sheet exactly, but a sheet. And the sheet is called data, which we've been using in our examples before. So once this workbook object is created, I'm not going to use the entire workbook. I'm just going to use a subset of it, which is the data sheet. This is going to be stored into a variable name called worksheet. Okay, so load the workbook method, pass it the Excel file. This is going to create a workbook object for us. I'm going to call it workbook. Then let's be more specific, get the data sheet from that workbook and then assign it a variable called worksheet. So now that we have a worksheet, the right worksheet, which is data, then we're going to adjust the column widths of all the columns in that sheet. And the way to do it is we're going to do a for loop. Column is the iteration variable. You can call anything you want. So for every column in columns in my worksheet. So the columns in this worksheet, which is the data sheet, I want to loop through every single column one by one. What am I going to do in it? Well, this is the code that I'm going to do inside these columns. First, I'm going to create a variable called max_length, and it's going to be set equal to 0. Then I'm going to call the getColumnLetter method, which is part of OpenPyXL, which is actually part of the utils class in the OpenPyXL library. And I'm going to capture every single column one by one. I'm going to get the letter of each of these columns. And well, again, since I'm looping column by column, on my first column, I'm going to get the letter, which in this case should be A, and that's going to be my column letter. Now, I have a nested for loop, so I have a for loop here, then I have a nested for loop here. Now I'm going to loop cell, which is my iteration variable, in every column. So every column in my columns in my worksheet, which is my data worksheet, I'm going to go through every cell in that column, and I'm going to do a try except. Now in the except here I have a pass because I didn't code what will happen if there's an error, but that's why I have a pass here. So I'm going to try. I'm going to check if the length of my value of my cell, remember I'm already looping in my first column, and now I'm looping in my first cell in my first column. So my first cell, I'm going to get the value of my cell, I'm going to get the length of it, and if the length of my cell, meaning that if it has values for the, if it's a word, if it's a number, it's going to have a number of characters. If that number of character is greater than the max length, which so far is defined as 0, then this condition is going to answer to true. Then I'm going to enter this indented code. So what this is going to say is, okay, then since the value of my cell has something in it because it has a length of more than 0, then I'm going to set this length value to my maximum length. So it's not going to be 0 anymore. It's going to be whatever the length of this value is. So if I have for example, it's going to come to here, and it's going to say, okay, so this is a length of 1, 2, 3, 4, 5, 6, 7, 8. So this has a length of 8 characters, which is greater than maximum length, which is 0. Then I'm going to set my cell value length to maximum length, which is going to be 8. So now maximum length is no longer 0, it is set equal to 8. And then I'm going to loop through column by column, cell by cell, doing all that. And at the very end, I'm going to get the maximum length. I'm going to set equal to a new variable called adjusted width. And then this adjusted width is going to be assigned to the width of the column letter. So again, A or B or C and so on, of the column dimensions of my worksheet. So every column, A, B, C, or D, is going to be set equal to whatever the adjusted width that's been calculated based on the different cells and the different columns in this code block. So what this is actually going to do is that it's going to take every column in my Excel sheet and it's going to set it equal to the width based on this width here. And this width here is going to be based on the largest cell value of my data. Once I have that done, then I'm going to call the save method on my workbook, and I'm going to save it as coffee final XLSX. So let's run all this and see what happens. Okay, there is no output, but the output is all the Excel files that I've been working with. So let's go to that. And here you can see that I had the original coffee shop CSV file, and then I have the coffee_original file, and then I have the coffee version 3 file, and then I have the coffee version 4 file, and then I have the coffee final file. So let's take a look at the coffee original. Okay, here it is. And then let's take a look at the version 3. Here it is where we added the record column. And then the version 4 is where we sorted by the total column. You can see here that, well, actually let me enlarge this for you. So here the total column now has been ordered correctly from smallest to biggest. And then the very last final one, the coffee final file, now you can see that the width of the file, width of the columns are much more snug as opposed to, for example, this one here. So see here how there is space. Let's see if I can do this. There we go. So this is version 4. This is coffee final, and you can see here that the columns are a little bit different, snug, compared this one to this one. So this is my version of the code for the Python assignment. Please make sure that you also create a Loom video or some sort of a video explanation that talks about your coding logic. Also, don't forget please to add comments. Okay, so comments is part of the best programming practice, so please do add comments to your code. please create a video. If you can't create a video for whatever reason, please create a Word document that explains what the code does. And please don't forget to also do the second part of the assignment, which is the R code. So I hope this was helpful. If you have any questions, please reach out at any time. And I look forward to seeing you in class. Take care and bye for now.